Hey everyone, my name's Nathan Rowe. I'm an ecologist in the Sonora, California office for the NRCS, and I wanted to go over some work that I've been doing for verification projects. Um, so verification projects is kind of a new task that a lot of our ecological site specialists are assigned with. It's basically to take ecological sites, move them to verified status, coming from draft or provisional or something like that, and um, it outlines guidance and requirements for what kind of information is necessary for a site to meet a verified status. So to begin with, I'm going to show you how to access the information that I'll be referencing here. So I Google Nathan Rowe GitHub, and for me, it's the top result, Nathan Rowe, Nate A. Rowe. That brings you to my GitHub, and this repository here, ESS underscore FAQs, is where I'll navigate to. If you scroll down, there's a link here, and that'll bring you to a site where I populate a variety of kind of discussion and methodology for ecological site information. If you scroll down to section 7, it's titled ES verification. So scroll out just a little bit here. So this is about ES verification projects. It provides some information about guidance from the national instruction and links to the national instruction, which has all the required information for ES verification projects. I share just a little bit of it here that's relevant to the methodology that I'm discussing. Um, so here's a screenshot from that national instruction, and it contains a bit of material that's particularly relevant to what I'm doing here. It kind of mentions the data requirements and the documentation and sampling that is required to meet a verified status. So you can see here in a minimum of 20 low or medium intensity observations or 5 observations per soil component. I'm not going to read all this, but it goes on, and there are other requirements as well. Things like in D, all plant communities in the STM must be documented with at least one observation in the veg plot object in NASIS. You need your sites to cover a geographic extent of the ecological site, and so on. So what I'm going to show to you here is a methodology that addresses some of those criteria that are outlined for meeting a verified status. So the goal of the workflow here, it's basically to allow you to see which ecological sites in an MLRA have sufficient data to become verified, or maybe none of them have sufficient data, but which ones might be low-hanging fruits. They have you know more documentation than others, and you can kind of rank things and prioritize them based on what data is available. And as a part of this, there are working groups where you're supposed to work with interested people. So that's part of the prioritization step. But in terms of just understanding where you're at with the data that could meet the requirements for verification, this kind of goes over some of those elements. So things that are going to be reported here is things like the number of pedons and the number of veg plots, as well as are they co-located together, so that we can understand a bit about the soil and plant relationships. Are there states and phases that are documented? Is there canopy cover by species that requires both a plant symbol and some element of cover? Is there strata, so on, things like that. There are also elements in here that aren't listed in the national instruction, but could be useful metrics of data quality, like is something a component pedon? What is the taxonomic level of components correlated to ecological sites or pedons correlated to ecological sites. So there's two main outputs that this workflow is going to produce. So here I will zoom in a little bit more. The first one of these outputs is really for this process of prioritizing or evaluating which ecological sites have uh, reasonable documentation, or just understanding, which sites have what data. So you can see here it's kind of small, but this first column here is ecosite ID, and we can see, for example, ecological site F018XI202CA, and several other ecological site IDs as well. And then there are a variety of columns. So the first column, pedons, how many pedon observations are there of each ecological site? Then we see eco-state ID and community phase ID. So how many of those site observations have an ecological state and a phase identified? How many of the sites have plant abundance? We mentioned that requires a plant symbol and a column for cover, of which there are several columns in NRCS that could qualify, and this process integrates all those different possible columns. Then there's strata, which similarly, there are multiple columns that could qualify for strata. Then there's the number of components. There's the acres. These are components that are correlated to an ecological site and the associated acres. How many of those are major components? And then series, some taxa information, like is it identified to series, taxadjunct, family, taxon above family, variant, so on. So this output is intended to allow you to make an evaluation of where the data is at. And then you could choose one of those ecological sites and want to get additional details on them or on that site. And so that brings you into this second output, which is looking at just the ecological site that you're interested in. Maybe you've chosen this, you're thinking this could be suitable for a verification project. And now it shows the information with a bit more granularity. Now you're looking at things at a site level. So the rows are sites. These are all for the ecosite 18XI202. And you can see the site ID, the site observation ID, a veg plot ID, and a pedon ID. So we know now that this has co-located veg plot and pedon, which not all sites do. We see representative one. So this is a representative pedon, which is could be a metric of the quality of that pedon and observation, whether it has the ecological state and phase identified. And then it goes on, there's several more columns that you can't see here, but it gets into things like what canopy cover columns are used, if any, things about strata, the plant symbol, the cover, and we'll look at this in the final output in more detail, but this is the type of information. So the intention of this output is basically you can start assembling, okay, which sites could be used in my 20 low to medium intensity observations of this ecological site, and could be kind of high quality observations that you rely on to describe both the abiotic and biotic features of this ecological site. So now we'll move into how to actually produce this information. It starts with querying NRCS. So we're going to use two different queries. The first one is going to get all of our site, pedon, and vegetation plot information. And then the second one's going to get all of our component data. So let's start with query one, which is going to be site, pedon, and vegetation plot data. So I'm going to go to NRCS. I'll just close out of the things that I'm already in. And I'm going to clear my selected set. And so let's see, what was the, we'll come back and see. So I'm going to use the query from the Southwest region, and it's called Sites by Site ID with percentage, which is a wild card. Um, so I have that in my favorites, and you should be able to find it um, by navigating to the Southwest folder. So here it is. There's some instructions here. I won't read them all, but what I'll mention is that this percentage sign is a wildcard. So it's intended to allow you to do some kind of pattern matching um, approaches. So we can choose here with target tables, site, pedon, and vegetation plot. So a site, um, so this is probably a situation that you've all encountered different times, but some of these queries require running them twice. And so in this situation, we're going to run this query twice, once with pedon and once with vegetation plot. And that's because site uh, and site observation kind of forks. At a site observation, you can have a pedon, and you could also have a vegetation plot, or you could just have a site observation with only a pedon. And you could also have a site observation with only a veg plot. And so pedon and veg plot are not kind of within the same hierarchy. They kind of fork there. And so we'll run this first for pedon because we're interested in pedon data, both site and kind of that pedon soil data. And what I'm going to do here is I'm going to use a pattern because I'm interested in running um, this whole workflow for an entire MLRA, and I'm running it for MLRA 18. And so what I'm going to do is it's MLRA 18, so that's 018, and then an X. So you want to use this code, and then I'll put a wildcard on the end as well. The reason that I'm not just doing 18 here is you're going to start picking up other eco sites that are from a different MLRA or something, and it just has an 18 in the code. So you want to kind of use your entire MLRA information. Another MLRA that I'm working on is 22A. So 022A is how I would query that if I was interested in the entire MLRA. So I'm going to run this for 18. So I'll do 018x run. So we had 880 sites located and 883 pedons. So some sites have multiple pedons. I'm going to accept this. And then once this is completed, I'm going to run the same thing, run against national again for my vegetation plots. All right, so I've accepted all of those. I'll run again against the national database, this time with vegetation plot. Wildcard 018x, wildcard, run. See how many vegetation plots we have compared to the 880 sites. So 3,000 sites are getting picked up with vegetation plot. Okay, so this is a situation that all of you won't see very often. It took me a minute there to figure out what was going on. So I'm going to accept that in. So what we had happen in MLRA 18 was there was a state project called Veg Camp that had a lot of vegetation data. that we imported in. So as a different project, we imported that veg data into NASAS. So there's no soils data attached, but there are all of these vegetation plots. So that's why we have why we have many more vegetation plots matching that pattern for 18 than we do pedons. And that's something that not too many of you will probably see. You'll probably find that you have far fewer veg plots than you do pedons. So kind of a little nuance for this project. So as this is finishing up, then I will um, run against my local database, and I'll do site, head-on, vegetation plot, same pattern, 018X, and then a wildcard at the end, adding them to our selected set. So we can see that there's those 3,000 plus sites and veg plots and 883 pedons that we're bringing into our selected set. Now we're going to go over to R and or first we'll come back to this document, which I'll zoom out a bit. And we'll look here. So we've completed we've completed only our first query of NASA. So we have another query that we need to do. So we got all of our sites, pedons, and vegetation plots. Now we want to get our components as well. And what I do for this process is I click this link, which provides me with all the MU keys in an MLRA. So we come here, and this is kind of, you can put in any MLRA here. So I have 18 in here, which is what I'm going to be using, but you can put in 22A and apply the changes. And these tabs here are going to provide you with all the MU keys. So why are we using this approach? Another approach that you might use is within NASAS to use the overlap tables for map units that defines what map unit is associated with what MLRA. And that's a population that's supposed to be used. It looks in the database and says, what is the link between map unit and MLRA? And you see queries and reports possibly that reference things like overlap tables. So that's what the overlap is referring to, is kind of a linkage that exists in the database. Those linkages, unfortunately, are not always populated, and so that creates a little bit of possibility for missed data. So the approach that this takes instead is more of a spatial approach, using the MLRA lines and pulling the map units associated with the MLRA. So there's reasons why that's not perfect either, but general consensus is that is a more robust approach than the MLRA overlap table. So you put in your MLRA, there's a membership, which basically says how stringent do you want to be on the criteria for what map units are in an MLRA. So this is saying if a map unit has 10% or more of its area within MLRA 22, I want it to be reported to me. So I'm going to put 18 back in here because that's what I'm going to be working with. So I have 18 in here with a membership percent of 10, and I grab all of my MU keys here, copy those, and then I'm going to come over, and as this document states, I'm going to use this query NSSC Pangea area legend map unit DMU by record ID legend map unit IID. So kind of a little database, esoteric thing. MU key and L map unit IID are synonymous. So this, we just got MU keys. They're the same thing as legend map unit IIDs. So we're going to come over to NRCS and we're going to find that query, which I also have that in my favorites, and you can find in this NSSC Pangea folder. We're going to go run against national database. And if we hit legend here, it's going to pull everything. Legend, map unit, data, map unit, pet on site. So we already have our pet on sites and transects. So we don't actually even need that. So unclick those. We're just trying to get our components now, which fall within the data map unit. We paste in all of our MU keys. We hit run. And once we have this, we're going to have all of the data in our selected set that we want. So that was sites, head-ons, vegetation plots. Now we have components. So that's kind of all of the different pieces of this puzzle that we're interested in to describe how much support is there for an ecological site. And that's really the information that you're using for that is site, pet on, and veg plot. But then you're interested in how large of an area does this site occupy? That's going to be related to component, how many different components, that ties into some of the criteria. So we're going to accept all of this. And while that's running, let's take a look. We'll open up a new R script. And there's a few little things here that, you all can feel free to ping me and ask questions. But so we have our data in NRCS now, and we want to bring that over into R. And if you've taken the Stats for Soil Survey course, you've already gone through the process of connecting R and NRCS so that R can read data from NRCS into R. If you haven't done that, in the introductory section of this document, you should read through the introduction, and it's going to mention this ODBC connection, which is how we are able to access data from NRCS into R, and link to the pre-course assignment for the Stats for Soil Survey course, which goes over how to make that connection so that you can use the methodology that I'm looking at. So there's a little bit of pre-work that needs to be done if you haven't already gone through that step. So while that's still running, now we'll open up a new R script by hitting this little tab up here, and we'll come back to our document, and we'll come back down to the section that we're interested in, which is 7, the ES verification. And we'll copy this first little section of code. So this is accessing data from NRCS. So you can hover over here and there'll be a copy to clipboard button. And then you can bring that over and paste that right into your R. And then, just checking on that. Then there's a second section, which is summarizing your data. And we can copy that section, also bring that over into R. And you'll notice that I am referencing and naming things MLRA 18. You probably want to change the name. So you can use a find and replace. So I'm doing a control F. So you could, highlight MLRA 18, control F. And then the find is on the left side and the replace is on the right side. And you could change this all to MLRA 17. And that should be pretty safe that you can just do a replace all, changing 21 occurrences. That way it just refers to the site, the MLRA that you're actually working in. That'll be a preferable way to do that. just to make sure your documentation looks correct. I'll change that back to MLRA 18. Let's see how NRCS is doing. Maybe it's getting there. It's okay. Oh, yep. All right. Okay, so we just ran that. Preparing number of data objects found 28 legends, 6,400 map units, 58, 5,900 data map units. Um, so now we'll come over here and run against the local. And we'll do area, legend, map unit, data map unit. And we just lost my, need to go back and get that list of MU keys. So let's come back here, copy that again. Then we're going to come back over here, run against local, area, legend, map unit, data map unit. Paste that in, run. All right. So those were added to my selected set. One thing that I'll mention with pulling these MU keys is that NRCS only allows, I think it's 20, I forget what it is. I think it's 2,400 different inputs, so each of these is an input one, two, only allows 2,400. So if you have a large MLRA like 22A, which is another site that I work on, and you're in this general information tab, are there multiple groups? Yes, make sure to check for multiple groups. That means that group one's populated, and that's 2,400 MU keys, which is the max that NRCS is going to accept at one time. Then there's group two. And so you're going to need to go through and run that query twice to bring all of those MU keys in a situation like that. So now we've brought in our sites, pedons, veg plots, and component data now. So now we're ready to run this script. And let's come over to our script. Now we'll run, we'll load the soil DB and dplyr library. We'll, and what I do here is hit Control Enter. So the cursor is on a line, for instance, library, and I would hit Control Enter, and that's going to run that line. So we just ran MLRA 18 veg. I'll put my cursor down at MLRA 18 pedons, Control Enter. Now it's running that. And it bumps, naturally, when you hit Control Enter, it bumps that cursor down another line. So you can just kind of keep hitting Control and Enter as it completes. So now I'm just hit Control Enter again. Now we're getting our components. And this is using soil DB functions, fetch NRCS, and some ecocitar functions, which are ecocitar is a package that I maintain. So then we'll come down and get our MLRA 18 component pedons. All right, so now we have all of that data that we've pulled into R. And now we're just going to run through, I'm not going to go over in too much detail what exactly this is doing, but it's basically looking through all that data and merging it in ways to get it all in the right places and changing the format of it and everything like that. And so let's just hit Control Enter. This stuff should run pretty quickly. You should read the warning messages. So this mentions there are multiple abundance columns used in this data set, AK stratum cover class percent and species canopy cover percent. Um, the function merges those all together. So that's an advantage of using this, is it's going to take all the different possible columns where a cover estimate could be used and kind of merge that into one so that you're not missing anything. Now we're going to run MLRA 18 components mod. So we'll just start kind of firing through some of these things. I'm hitting Control Enter, and I'm running through some of these things. And we hit the end of our script. So now we have created the two objects that we're really interested in. It's MLRA 18 triage summary and MLRA 18 ecosite triage summary. So to begin with, let's look at this MLRA 18 ecosite triage summary. So I'm going to do down in my console here, capital V I E W for view, and then MLRA 18 ecosite triage summary. R will help you and kind of show, pattern match once you're getting started. I'll hit Control Enter. And now this brings up all of our ecosites that are in 18, and then it's going to show all the pedon, state, phase, all that information that we were talking about earlier. And so then I can start filtering things by hitting these columns here and looking at, okay, which ecosites have the most pedons. This XI 202 has 99 pedons, no state or phase populated. Quite a bit of veg data. There's 166 sites where there is both the plant symbol and a cover column used, and so on. And you can see, there's kind of a balance here between, we have a lot of pedons, but maybe it's a really large ecological site correlated to a lot of components, or, covers a lot of acreage. So you want to consider things like that. There's also an approach for the verification project of low-hanging fruit. So you might look for something that has a small number of components. I believe the guidance says 5 observations per component. So if you find something with just a couple different components and you already have, 3 pedons, and this looks like it has 34 different sites with veg data, they're not going to be a lot of them co-located veg and pedons because we only have 3 pedons. And that's probably, like I mentioned, we imported a lot of external veg data into NRCS. So that's probably why we have a lot of that. But just to start looking at, there's a small number of components, I already have a few pedons and veg data for that. This could be a site that's easily moved up to the verified status. So a couple different options there. Let's say that we decide we're going to go for one of these sites that has a lot of data, 99 pedons. Then if we come back to the script that we were working on, so we just looked at the last object that we created, which is called MLRA 18 Ecosite Triage Summary. The second to last object is called MLRA 18 Triage Summary. So if we go to that, MLRA 18 triage, sorry, I'm going to Control A and delete that. I want to do view, and then MLRA 18 triage summary, Control Enter. Now that brings up a different data frame, which there's this button here that says filter. So I'm going to hit filter, and then in the ecosite ID, I just copied the ecosite that I was interested in. I'm going to paste that in there. And now all the results will only be sites where that are correlated to this ecological site. So there's 166 of them, it looks like, from showing up to 166 down here, I see. And there's lots of different columns. So the site ID, the site observation ID, veg plot, pedon. So we're seeing here that there's both a veg plot and a pedon at this location. So that's co-located veg plot and pedon, which is useful for determining those plant soil relationships. Is it a representative pedon? False. No, it's not a representative pedon. So that's a metric of quality that you might want to consider. It doesn't mean that it's not high quality. Um, and then we see, yeah, the state and phase. So this does not have state or phase populated. Then it goes through a variety of these columns, overstory canopy class. So these are columns that come out of NASIS, and they're things that would qualify um, for either strata or cover by species and things like that. So then if we, that's kind of in great granularity there. But if we scroll over a bit, we can see kind of some more summarized columns. Um, and we can see the strata logic. So the strata logic says true. It's saying that there is a strata populated. So one of these strata columns is populated. And we can see here that high class, low. So this is kind of the lower part of the species and the upper part. So these are columns that come from NASIS. So it's satisfying the requirement of having strata. So it meets that. So we can see that strata logic true, plant abundance logic false. So something's happening here where we have um, plant sim is true. We have a plant symbol, but we do not have species canopy cover or any other column that qualifies as canopy cover. So we know what species is there, but we don't know what amount. And that's not going to meet the requirements for um, canopy cover by species. So that's a false there. Um, so you can look through some of those things and start to ascertain what they mean. You can also, if there are questions about what some of where some of these things exactly come from, you can look in this code and see things like total canopy class equals canopy cover class total. And you can track these things down if you want to get into the granularity of all this. You can go and look at the names of these columns in NASIS, and you'll find that they match up directly to this. And I realized that it's a little bit difficult to exactly, determine what are some of these things. The names don't shed, it's not totally transparent what they are, but you can track these things down. You can ask me um, anything like that. And then there is also um, a sum logic. So this is basically an overall metric of how much information there is about this, how many kind of attributes are meeting criteria that exist in the verification project. So you can just sort that highest to lowest, and that's kind of an overall heuristic of whether it's meeting things or not. So the higher numbers are going to be meeting more of the criteria, and you can look through at these logical true falses to see what's being met and what's not. But the overall intent of this is to be able to identify site IDs, veg plots, pet on IDs, things like that, that you can say, this is a site that I'm choosing that has high quality data that I'm going to use as supporting evidence for my verification project. One of the things, then this other column here, and I'll put out some documentation on exactly what these columns are, because as I'm describing it, I'm realizing just how confusing this could be for all of you. So there'll be in a kind of appendix document that describes these things. There's some logic, no can, and can refers to canopy cover. Um, so I believe that's total canopy cover. I'll put out um, overstory canopy class and total canopy class. Some of those things I think are kind of difficult metrics because they have to be recorded on the ground. You can't take canopy cover from individual species and add them up to get a total overstory, a total canopy class, or an overstory canopy class, because things overlap, and overlapping things, you're starting to add canopy cover that shouldn't be added. So canopy cover is not additive. And so I put a metric of not including, kind of a logic of how many criteria it meets, but excluding um, that canopy cover class, because I think it's just a hard one to necessarily meet it. And I don't want people to look at historic data and start throwing things out just because it doesn't have this total canopy cover class. When I think there's a lot of information that can be understood from just the species canopy cover class. If you have species canopy cover class, a plant symbol, and something about the canopy cover, I think that for a lot of purposes, and this needs to be hammered out in some of the um, protocol stuff about whether you meet low, medium intensity without a total canopy cover class that, like I mentioned, is hard to recreate for plots that were sampled in the past, and there's no real way to recreate that. And so that's the general idea there. So after that little tangent, that's about the end of this methodology. So that goes through the overall process, and these these tables are a little bit harder to see. This is just kind of the way that a basic um, visualization of these tables is displayed. But we looked at those in we looked at both the ecosite triage summary, which allows you to kind of choose which ecosites might have um, a, enough data to meet a verification, or what additional data is required, and then choosing one and looking at kind of the actual details, and what sites, head-ons, veg plots might be usable for documenting your site. So I'm going to put a few more things. One of the other things that I am going to share is, once you choose a site and you look at some of these, at what data there is, this is things that are correlated, that are kind of easily accessible. But I'm going to put out some information about how also to find additional pedons that maybe are within your map units, that are associated with your ecological site, that aren't, these pedons aren't correlated to an ecological site currently. So how do we find those pedons and look at those and be like, hey, that's not, oftentimes pedons are not correlated to an ecological site, or sites aren't. But how can we locate those and determine, oh, we actually have some additional pedons because this is, I think, a good correlation to my ecological site. And same for vegetation plots. So some ways of this axis is kind of like the easiest data that's, the correlations already exist, but I'm going to go over some ways of accessing data that is maybe a little bit more hidden. And I'll also show you, I don't have the code up for this right now, but I'll show you how you can also easily produce kind of a visual of what's the extent of my ecological site, which is the polygons in red, and what is the extent of my sites. Because one of the criteria for the ES verification is that you cover the geographic extent of your ecological site. So this will be an easy way to kind of pull that data as well. So that's about it. I'm going to end there, but thanks for tuning in. And yeah, feel free to reach out with any questions that you have, and hopefully this is useful. See ya.